I'm introducing the concept of Network Connectivity Proxy, or NCP for short, which allows to make a more efficient use of the standby states already available in most computers and in many ICT devices. The design, implementation and standardization of the NCP are jointly addressed by the Italian National Inter-University Consortium for Telecommunication, by Infocom, an Italian SME, and by Telecom Italia with the support of the German Lantic. The Network Connection Proxy is a low-power network entity that acts on behalf of other devices. The NCP maintains the network connectivity for the sleeping networked devices and wakes them up when needed. This way, the covered devices looks always on and available to their peers. Now, let's take a quick look at what the NCP concept involves.
Consider the scenario of a local area network where a computer is idle and is put in the standby mode by its power management software. The most common sleep mode for quick availability is the so-called suspend to RAM. All device hardware is powered off, but the memory and the network interface card. In this state, the device cannot answer ARP or ICMP request. It cannot take part into protocols like NetBIOS, Bonjour, UPnP, and it cannot refresh soft state by keep alive or earth-beating messages. This usually turns into unreachability errors for any host trying to access the sleeping device. Indeed, the sleeping host network interface card remains powered and it can wake up the host on the reception of wake on LAN packets. However, this would require any host to be aware the peer is present and sleeping and to send the wake on LAN message. Instead, if an NCP is present, it intercepts the traffic addressed to the sleeping device and answers on its behalf. This way, the NCP hides the current power state of the covered devices. The communication interface between the NCP and the covered devices should support mutual discovery, event notification, and remote procedure call and registration. The client devices should instruct the NCP about the network services they need while they are sleeping, and then should notify the NCP when they are going to sleep. The NCP operates on their behalf until their wake up. UPnP, web services and SOAP are all technologies suitable for the implementation of such communication infrastructure. Our demo of the NCP capabilities covers a typical home scenario that includes devices as a set-top box, a XDSL modem or home gateway, laptops and desktops. In our demo, the NCP is supported on the home gateway device. We will show how the set-top box discovers the presence of the NCP and how it registers the request to be woken up when the user requires to access a video. Then we will put the set-top box into the sleep mode and we will demonstrate that it will be anyway seen as up and running by a client, as the NCP will answer the ping messages on its behalf. Finally, we will show how the set-top box is woken up and becomes ready for service when a user simply requests a video. Our demo includes the minimal set of devices that are suitable to demonstrate the NCP function. First, we have the set-top box, which is emulated by a small PC with similar power requirements. A power meter measures the set-top box power consumption to evidence the actual device power state during the demo. Then we have a laptop, which the user will use to watch a film stored in the set-top box. And we also have a development board, which implements an ADSL gateway where the NCP service will run. All these devices are connected via a simple switch. Let's see now how the NCP works. When the NCP is started, the UPnP interface advertises the service on the network. Once the NCP client sees the advertisement, it knows an NCP is present and can register with it. Then, the set-top box registers the requested actions, including the support of ICMP on its behalf and the wake-up conditions. Now, the set-top box is unused, so it can enter the standby mode. As we can see, the power consumption drops from 23 to 6 watts. Once the user sees at the laptop, the set-top box is still sleeping, but the NCP hides this condition. Indeed, if the user tries to ping the set-top box, she'll get an answer as the device were up and running. The green window is showing the NCP activity log. Finally, the user requests a video from the set-top box. The NCP detects the connection request and wakes up the device. The power meter shows the device is back to the active state, and the user can now enjoy her video.
Let's now see what the NCP can really do. Our NCP can currently answer ARP requests, it can answer ICMP equal requests, it can send periodic DHCP renewals, and it can wake up and host in case of a new TCP connection request. The design also includes the host wake up on specific packet arrival and the reply to a packet with a predefined packet. Now we are working to extend this behavior to support more challenging functionality. In particular, our goal is to keep TCP connection alive and to provide the support of generic applicative heartbeats. If you are interested in more information and wish to collaborate with us, please visit the project website. Thank you for your attention. Bye.